The Brainiac Corporation. Every day, a crack team of Britain's finest minds get to grips with the fundamentals of scientific knowledge and understanding. So welcome. Step inside.
Hello.
But be warned, only the hardiest of souls and strongest of stomachs can survive the worst excesses that are Brainiac. Science abuse.
Brainiac. 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 Brainiac.
Welcome to Brainiac, an itchy rash on the buttocks of science.
The big science tonight. Another day at the office, Brainiac style.
Blast off!
Something's gone off at the lab. And hold on to your hats, it's Super Brainiac. But first...
Hello! Is liquid nitrogen again. Liquid nitrogen is miracle, can transform ordinary into extraordinary. Today, it's the time of the rubber band. Ursula, please bring the rubber band. Ursula, thank you. That is her favorite game. Ursula is so happy today as she has a new shoe. Before rubber band meets liquid nitrogen, it acts like this, springy round. Now I introduce rubber band to liquid nitrogen. Rubber band spends his whole life oval, but now is oblong. What is happening? Rubber band returning to its original form, like a worm in a cadaver. Back to round rubber band, ready to keep Ursula's teeth in position. Liquid nitrogen, I salute you. You are a miracle.
Hidden away in a secret outbuilding is the Brainiac slow-motion research facility. Inside, a small team of Brainiacs are devoted to the remarkable line of research we call things, but very slowly. So what's this week's thing, but very slowly? A wet dog. Normally, this isn't particularly interesting to watch. But let's see that again, very slowly. Seen 400 times slower than usual, the dog's fur moves in spiral waves from the head towards the tail, creating a galaxy of water droplets in the air. It takes less than 1/5 of a second for each full shake, the force of the oscillations violently whipping the ears from side to side. In real time, it takes just a couple of seconds. A wet dog. One more thing, but very slowly.
The humble hat. Designed for comfort, but also as a means of protection from impact. But if you had to choose just one hat for year-round multi-purpose protection, what hat would that be? Which is the world's hardest hat? We've got together a collection of headgear, some more protective than others. Here is the traditional construction site hard hat, or hard as it's known in the trade. If you've ever had a hard-on, you know it's got to be rock solid. The sombrero, which offers protection to drowsy Mexicans in places like Great Yarmouth. And the pith helmet offers protection from falling pith.
So which one will be the best at resisting hard knocks?
To help us find out, we've got the ultimate in dangerous falling objects, the anvil. And somewhere up there from which to drop it. Brainiac, begin ascending the tower. Now, sadly, we're not allowed to drop an anvil onto the Brainiac, even if they are wearing a hard hat. So, we've got the next best thing, a melon, which some say is more intelligent and will do what it's told when it's told. Release the anvil!
Our exhaustive test reveals many hats offer almost no protection at all from falling ironmongery.
Oh ho ho ho!
The topper is totaled. The bobble's bleeding useless,
Whoa!
and the pith lives up to its name. Predictably, some hats do well.
Yes!
Look at that helmet, not a scratch. And it's a surprise result from the saucepan.
Not a lot of damage at all, apart from a little bit of a dent there.
So, 27 and a half hats later, the results are in.
Well, the clear losers in our test under sustained attack by anvil, they can go. Our finalists are the fireman's helmet, the coppers, the construction workers, the soldier's helmet, and of course, the saucepan. But we need to find a more destructive way of putting these hats to the test.
It's all very well testing hats for impact from the outside, but what about from within? How would these hats hold up if your head suddenly exploded?
Brainiacs, put on your personal protection equipment as I put mine on, and hold on to your hats. Fire one! Oh, hats off! Fire two! Ooh, fire three! Bingo! Fire four! And the head blew off with it! Fire five! OK, let's go and examine the residue. The fireman's helmet, split. Army hat, as good as the day it was made. Saucepan, almost intact. The handle's gone, but that's OK. Construction site hard hat, virtually nothing left of it. The copper's helmet, fine. That leaves me with 3 finalists for the final test of hat hardness.
But what can subject the remaining headgear to more force than this? A 10-ton vibrating road roller can!
Otherwise known as Big Julie.
This beast can flatten an acre of tarmac faster than you can say out-of-town retail development. If you're getting nervous about how unprotective these so-called safety helmets are, just look what happens when you don't wear one. Time for the hats. First, the saucepan. Ouch! On the plus side, the non-stick coating has worked a treat. It's not stuck to the wheels. Next, the policeman's helmet. Can the bobby dazzle? No. And finally, the army helmet, made from Kevlar, a startlingly strong material, also used in bulletproof vests.
Let's inspect the damage. First, the army hat looks pretty intact. The English bobby's helmet, crushed out of all recognition. And finally, embedded in the ground, is the saucepan, which might be used for making pancakes now, but conclusive proof that the hardest hat in the world is the army hat. The speed of light is 670 million miles per hour. The speed of sound is about 770 miles per hour. But what's the speed of smell?
Over at the Brainiac lab, we're setting up a test to find out how fast smells travel. This is ground zero, from where we will shortly be releasing 3 of the most pungent and therefore quickest smells. The Brainiacs, sitting at equal intervals from the epicenter, will indicate they've noticed each odor by making a sound. But how quickly will the smells cross the room? We're ready for smell number 1. Dog dirts. Dog poo smells because of compounds and gases given off by bacteria from inside the dog's gut. In a matter of seconds, the Brainiac at Ground Zero smelt it. A meaty bouquet of digested dog food, and 10 seconds later the smell has travelled 1 meter. Make that 2 in 26 seconds. The further the smell moves or diffuses, the more diluted the odour molecules get. And the less obvious it becomes. 3 meters so far, and 4. It takes longer and longer to reach the next distance marker. Bad news for the Brainiac sat at the front. But there you go. The dog muck reaches the 5-meter mark in 44 seconds. So, over 5 meters, dog muck's speed of smell averages at 0.11 meters per second. Or for the less scientific of you, that's just a shade quicker than a tortoise. But is there a speedier smell? How about petrol? Please note, this isn't an indoor liquid, and sniffing it is basically solvent abuse. So don't copy us. The can's barely opened and the first one's got it. Petrol is very volatile, meaning its molecules move easily into the air. 1 meter. 2, spreading very quickly. 3 meters. The human nose can detect some chemicals in far lower concentrations than others. 4 meters. So, petrol seems smellier and spreads quicker because it takes much less for you to notice it. And that's 5 meters. So, the full distance in just 34 seconds. Speed of smell, 0.15 meters per second, about the same as an automatic car window. Our third and final smell is the stink bomb. But using just one is for schoolboy pranks. We really want to break the smell barrier with this, so we're going to let off a whole packet at once. When smashed, these airtight vials release foul-smelling ammonium sulfide, the evil odor of rotten eggs and flatulence. Almost instantly, the putrid waft hits the first Brainiac. And then the victim sat at 1 meter, 2 meters, 3 meters. It's like chemical warfare. 4 meters. Still nothing in the back, though. But there it is, 21 seconds. So let's see the results. Fastest over 5 meters was stink bombs, clocking in at a terrifying 0.25 meters per second. That's similar to a guinea pig walking. So what's the speed of smell? It depends what you're sniffing, but if you want a fast one, go for a whole packet of stink bombs.
Things what my body does.
Hi, I'm Freddie Clapp, and the thing that my body does is this.
The outer ear, or pinna, usually acts as a funnel for noise, directing sound waves into the ear canal, but it can also act as an hilarious addition to the side of your head. Will it fizzle or will it flash? The chemistry conundrum as posed by Dr. John P. Kilcoyne, Principal Lecturer at the University of Sunderland. So, what chemicals does Dr. Kilcoyne have in his shed today?
Aluminium, iodine, water. Will it fizzle or will it flash?
Also to come, how rockets can help you escape that dreaded meeting. There's lightning down south for this weather girl.
It's going to be a show!
And it's Brainiac v. Monkey.
Brainiac.
This is Brainiac, the show that does for science what a pair of pliers does for toothache.
But first, Dr. John P. Kilcoyne of the University of Sunderland posed the question. Aluminium, iodine and water. Will it fizzle or will it flash? The answer? Fizzle! A few drops of water are all it takes to start a vigorous reaction producing aluminium iodide, clouds of purple iodine vapour and a fine fizzle. Nice one, Doc.
What a great fizzle.
Everyone knows that NASA is the #1 organisation when it comes to using rockets for science. But there's some stuff NASA never tried.
Cancel that parsnip soup, Miss Burbage. The office workplace can be a dangerous place. You never know when the next hostile takeover's going to happen. There must be some escape. So, can an office chair be turned into an ejector seat?
Brian here from accounts needs to be able to clear an entire building at the touch of a button.
To achieve this, we've attached 2 rockets, here and here, both delivering an incredible 110 kilograms worth of thrust in 1 second, sending our man here 200 feet into space. These fins on the legs here should hopefully send him directly straight upwards, thus avoiding any collision with middle management. There we are, the world's first office ejector seat. NASA never tried this out. OK, Brainiacs, clear the launch pad area, take off in T-minus 60 seconds. Final checks for office ejector seat. 3, 2, 1, go. Countdown in T-minus 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off!
Brian accelerates from 0 to 60 in under half a second and flies at around 100 miles per hour, landing safely in a nearby field.
Bingo! Like a yellow mannequin flying into space from an area of hard standing. Literally. Let's go and have a look. Oh! Look at that. Smashed to smithereens, there's hardly anything left for him. Although, look at the underpants here, almost intact. Results, please. Thank you. So, when man makes that business deal with aliens, you can't say that Brainiac scientists didn't have a little bit to do with it. Take that to NASA.
Here's one for you. Why do people say that they've slept like a baby when most babies wake up every 2 hours?
We're attaching electric cables to a well-loved, well-paid British celebrity. Will she still be able to do her glamorous day job whilst being electrocuted by our Brainiac? This week, it's sensational TV weather girl Claire Nasir. We've got a special weather report for her to deliver. Hello, Claire.
Hello there. Well, I've got some really bad news for you. There's a deep storm coming in from the Atlantic. It's going to be a shocking day today. British Isles is going to be whipped and lashed by rain and wind, thunder and lightning over the next 24 hours. This storm is marching in. It's the mother of all storms. From Penzance across to southwest Wales. You really are going to get it over the next... I'm talking lashings of rain. Floods. This storm is the most perfect storm. It's awful. East Anglia, even though you're on the eastern side, you are not safe either. No one's going to escape this really bad storm. Storm also coming in across the Ring of Kerry, up towards Donegal as well, and heading up towards Thurso in the far north of Scotland, thunderheads. This is full of thunder, lightning. It's going to be a shocking day. And even Orkney and the Western Isles will get it as well. Here's your summary.
So, can Claire still do her glitzy day job whilst being electrocuted? Yes! Thanks, Claire. Your lightning reflexes have done you proud. Next time, a hair-raising 2 minutes for the salon's Ricardo.
That's Wolf!
Ladies and gentlemen, welcome to the one, the only Brainiac for a Day, with your hosts, Dolly Boy and the literally stunning Dolly Girl. Every week, one lucky viewer gets to wear the famous yellow t-shirt and hat for a thrill-packed day as a Brainiac. This week's Brainiac wannabe is Derek, a warehouse worker from Worcester. Tell us, what is it you're going to be blowing up today?
Cabinet of ornaments.
And what a lovely cabinet of ornaments this cabinet of ornaments is! As a boy, Derek lived on a diet of spaghetti hoops, as his stepmother lavished all her meagre income on knickknacks and curios. Sometimes Derek wished he'd been made of porcelain too, then she might have loved him more. But before he can blow up anything, he needs to transform from warehouse worker Derek to Brainiac Derek. Now, he's got to spin the wheel of explosive truth to decide which chemical will be blowing up his cabinet of ornaments. Where will the arrow point? It's aluminium flash powder! What a surprise, and what a great result! Uh-oh, no time for celebration because there's the siren, the signal for Derek and our dollies to retreat to a moderately safe distance. Our explosive expert sets the charge. Aluminium flash powder is highly volatile, and when handling it, it's important not to panic. As always on Brainiac for a Day, our motto is safety first,
Brainiac second!
There's just time for Derek to prepare himself. And there she blows! What a blast! Good work, Derek. Everyone loved that one. Aluminium flash powder may sound like something you clean your kitchen floor with, but only if you don't mind doing your cooking and washing up amidst a steaming pile of rubble. Aluminium oxide, free elemental iron and a bit of heat, and the horror of porcelain collectibles is dealt a merciless yet beautiful blow by the magic of chemistry. That's one cabinet of ornaments that's way past its shelf life.
Thank you, Brainiac, for making me a Brainiac for a day.
No problem, Squire. Here at Brainiac, no one's more important than our beloved fans. Oh, and Derek, cheer up, son. You're on TV.
Come in. Stand over there for me, please. Right, Mr. Tickle, what can we do for you today?
Nurse, I'm bored. Can you show me something interesting I can do with my body?
Certainly. Try this. Please place one hand in this hot water and the other hand in the cold water.
Okay.
Now place both hands in this lukewarm water.
Right. Ooh, how strange. It feels hot and cold at the same time.
When you put your hands in water, the skin's receptors quickly become accustomed to the temperature. But when you remove them, a lingering after effect makes lukewarm water feel either very hot or very cold, depending on what each hand has got used to.
Thanks, Nurse. That'll keep me occupied for hours.
Not at all. Goodbye, Mr. Tickle.
Goodbye.
I can do science, me.
Every year, the I Can Do Science Me open auditions attract literally several would-be scientists. Not every idea is a winner, but our Charlotte is so dedicated to the cause that she will listen to each and every question the population wish to put to her.
Name, Serena. Number, 877. Dear Brainiac, as sound travels through the air, how loud would music have to be to blow out a candle? I'm not at all sure why you want to know this, Serena, but I am intrigued. Let's make some noise.
This is the science you want done. Come to us with your burning questions and we'll give you the tools for the job. First, we bring on a 5,000-watt sound system, which is capable of bursting the eardrums of the most seasoned clubber. Next, the Brainiacs sit Serena directly in front of the speakers, give her some ear defenders and a decibel monitor, light a candle, then retreat to a safe distance. sound from the speakers is a series of vibrations of the air we know as sound waves, or in this case, noise pollution. As the volume increases, these waves become more intense, causing greater and greater disruption in the air. At high volume, this disruption to the air could cause serious damage to the unprotected ear, especially this track. The candle is dancing to our tune. As the DJ cranks it up to maximum, the flame is actually extinguished. Remarkable.
Her name is Serena. She wanted to know how loud music had to be before it would blow out a candle. The answer? 107.7 decibels.
I can do science, me.
The monkey. Beat man into space and able to hang from a branch by 1 foot whilst peeling a banana with the other. The Brainiac. Unlikely ever to make it into space and displays all the coordination of a newborn hippo. Today they go head-to-head as we answer the age-old question, who's better at gambling, Brainiac or Beast? Tipping the scales at 80 kilos and standing at 174 centimetres, our Brainiac can boast of being at the top of the food chain. Monkey weighs in at a meagre 5 kilos and stands just 47 centimetres tall, but what she lacks in stature, she makes up for in attitude. We're giving each contestant £10 to find out who is the king of the slots. First up is Brainiac. Slot machines are programmed to pay out around 75% of the money that goes in as winnings, known as the theoretical payout percentage. Looks like our Brainiac is in the losing 25%. It seems a fool and his money are easily parted. Can Monkey do any better? Monkey has amazing hand-to-eye coordination, which is proving invaluable on the skill stop features. Monkey's naturally aggressive demeanour means she's willing to take more risks than our Brainiac, pushing each win to the jackpot. With winnings of £5, Monkey easily beats Brainiac. Well done, Monkey, but I'm afraid we're going to need that money back. Sorry. Next time, it's Brainiac versus Hamster. Dr. Bunhead on the pull, where every other Tuesday, science's biggest loser hits the town hoping his special mix of near-fatal charm and half-baked experiments will finally get him a girlfriend.
Hello. All right, do you mind if I have a seat? I tell you what, if I can use science to make a much more exciting drink, will you have a dance with me?
Excuse me?
Look, I'll show you anyway. What I'm going to do here is make a Dr. Bunhead super traffic-like cocktail. What colour is that? It's not a trick question, it's blue. Yeah. Now, here we go. I'll add some of this and... ta-da! It's turned to green. Look, it's gone red. The traffic light, orange, yellow. You like that, don't you? And what's even more spectacular is I have a chemical in here which takes up oxygen. So if I shake it, I get the oxygen back in, and it goes back to green again. Ta-da! And then it uses up the oxygen, and it goes back to red again. And then orange, and then yellow. For a dance.
Is that a chocolate coin around your neck?
I can do other stuff. Do you want to see my fire tornado? It's very cool. You forgot your drink. Well, actually, it's poison. You don't want to drink that.
Dear John, I'm a canoeist who loves a drink. Normally, I'm well in control of my bladder muscles, but when I'm in the canoe, the gushing water gives me an uncontrollable urge to take a leak, often with unfortunate consequences. The question is, which of my senses makes me want to go to the loo fastest? Dean of Templecombe. Well, Dean, accident prevention is something that we take very seriously here on Brainiac, so I'll be very pleased to help. I'm going to experience the sight, sound and feel of water to see which one gets me running to the loo the fastest. But first, I'm going to drink a yard of the stuff to get me in the mood. Thanks, Brainiac. Our brains associate running water with the splashing of wee. That's why being near a gurgling stream sends a message to a full bladder that it's time to unzip and let rip. But which of our senses gets the brain communicating with the bladder fastest? Ooh. Now, I'm going to listen to the sound of water, and this Brainiac is going to time me to see how long it takes before I have an uncontrollable urge to wee. Right, so you take that. I'll have that blindfold. Put it on, start the water and start the clock. The sound of water is picked up by tiny hairs in my inner ear, which trigger more than 1 billion nerve signals. They're sent to my temporal lobe, which in turn passes increasingly urgent messages to my bladder, forcing me to run to the toilet any moment. Reckon that's about it. Stop the clock. Now. So, from tap to toilet in 1 minute 39 seconds. Let's see if the sense of sight makes me go any faster. Another yard of best British tap water to make sure my bladder is equally full for the next stage of the experiment, watching silent footage of running water. The images of running water trigger reactions in the visual cortex of my brain, which should send angrily insistent messages to my bladder just about... Oh, that'll do. Now. From Gogglebox to Thunderbox in 2 minutes and 5 seconds. 26 seconds slower than the sound of water. Time to show some skin in the name of science. Oh, thank goodness for that. Right, what I'm going to do now is put in some earplugs and also put a blindfold on. That's to make sure that for the next part of the experiment, I'm influenced solely by the feel of water on me and not by any sight and sound. And to make doubly sure, Brainiac here is going to put a helmet on me. Off you go, Brainiac. As the water splashes over my almost naked body, receptors in my skin send signals to a part of my brain called the postcentral gyrus. This makes my brain shriek like a fishwife at my bladder until... Take me to the toilet, Brainiac. My bladder opens like a tropical monsoon. Right, what time was that, Brainiac? Oh, 1 minute 15. Oh, well, there's your answer, Dean from Templecombe. It's not the sound or the sight of water that makes you want to go to the toilet most, it's the feel of it. So if you can avoid that when you're canoeing, you can drink to your heart's content. I think we're going to need a bigger bowl.
Professor Mayang Lee, bringing beauty as well as brains to the world of Brainiac. Recently, the prof's been having fun in the garden with her new favourite toys, a stunning pair of steel balls. By abusing the gravitational field of the Earth using a piece of string and a stepladder, Professor Mayang is able to unleash her pendulous orbs on unsuspecting objects. Today, it's a set of Russian dolls. So, will Mayang Lee's balls of steel shatter or shunt the Russian dolls? Also to come, how hard is it to run through bamboo? How hard is Super Brainiac? And how hard is water when you fall on it from a height?
This is Brainiac, a gale force wind on the comb over of science.
But first, Professor Mayang Lee prepared to unleash her balls of steel on a set of Russian dolls. But will they shatter or shunt? It's a shunt! In a Newton's cradle of sisterhood, the flexible wood is able to transfer all the momentum from the steel balls to the baby doll on the end. Nice work, Prof. Ding dong.
Stop! The following recipe is dangerous. Do not try this at home. Or anywhere else, for that matter.
This week's recipe, beef Wellington. You will need beef, mushrooms, pate, and pastry. Wellingtons to taste. Just one tip. Don't, whatever you do, allow a light bulb floating in liquid explosive to get into the microwave cavity before switching on. 10 minutes on full power is normally plenty for this recipe, although cooking times can vary. As the microwave energy excites the tungsten filament, the lamp begins to glow, heating the liquid explosive to dangerous temperatures. It's a domestic white goods time bomb, waiting for the tiniest electrical discharge to go off, and it's culinary devastation. The beef Wellingtons met its Waterloo. We do these recipes so you don't have to. Do not try this at home.
Humans and water don't often get along as well as these two are today. Water can flood your house, you can drown in it. It's one of the key ingredients of sewage. If you drop on it, it can be lethal. So, at what height above water do you have to fall before it's like hitting concrete? Nothing hurts like a good belly flop. But from a certain height, the surface tension of the water won't just leave you slapped, it'll leave you split open like a kipper. This is John Tickle. What's going to happen, John?
Well, Vic, today we'll be dropping stuff into this pool to find out what height stuff has to fall from in order to be smashed up by surface tension.
Brilliant, so we're going to be dropping Brainiacs into the pool.
No, we're going to start off with melon.
Melons. Why melons, John?
Well, they have a thin but tough outer layer that protects their fleshy innards, much like humans.
And we've got one 10 metres up there. Are you ready with the melon? Will you drop the melon? Let's check it out.
Yep. Oh, it's intact.
It lives yet.
So, according to our crash test melon, if somebody belly flopped from 10 metres, they'd get a bit of a slap, but their body would remain intact. So, let's send our vertigo-suffering Brainiac up to 20 metres and see what happens then.
Are you ready with the melon? Let it drop.
Good bang, that.
It's split in two.
Oh, my word,
Look,
yeah.
it looks like there's pieces of brain floating about.
Yes, the chances are if you were to belly flop from 20 metres, you'd be split open like, well, a melon. But at the end of the day, it's only a rotund fruit. What we really need is something more like a human. Something with a body, hands, face. Something like... Yes, it's a grandfather clock. Unlike you and I, its hands bizarrely come out of its face, but it's got the same weight and body shape of a human being, albeit an old and flimsy one. So when it hits the water from a height of 20 metres, will its time be up?
Here we go. 3, 2, 1, drop.
Surface tension is caused by water molecules on the surface of liquid being pulled down by the molecules beneath them. They squeeze themselves together to counteract it, and the surface becomes hard.
Oh, that's pretty mashed up.
There's guts coming out of it. If a human dropped from that height, its innards would be strewn all over the swimming pool, even its haircut would have been removed. What would happen if, say, for instance, this oil drum fell from 60 metres? Would it buckle it?
You're proposing a test, are you? Metal versus gravity and water.
Come on, let's drop it.
Let's do it.
So, we know a human would be split apart after hitting water from 20 metres, but we've got a crane that can drop objects from a height of 60, and we paid for the whole day. So what damage will the hardened water molecules do to this steel drum from a giddy height like this?
Oh! It missed. It completely missed. Oh.
So that's what happens when a barrel misses a pool and hits concrete.
Yeah, that's quite interesting, you know, because now we can compare that to what happens when it hits the water.
So we can see whether the water tension is exactly the same as the concrete.
Another barrel.
Well, we've only got one more barrel, so once again we'll raise it to 60 metres, nearly the same height as St Paul's Cathedral. And let's just hope it hits the water. If it doesn't, this Brainiac's fired.
It's good, isn't it? There it goes.
Go on, go on, go on! Oh my word! Let's go round here.
Left to be completely flat. Have you got it?
Careful, careful.
Look at that.
Man, let me get the other one.
That's what happens when a barrel hits water. And that's what happens when a barrel hits concrete. Look at the difference.
Look at the
That's
awesome
incredible.
power of surface tension.
Well, if it can do that to a barrel, imagine what it could do to you if you belly flopped. Never underestimate the power of surface tension.
It's no laughing matter, John. This frame is filled with hundreds of stems of bamboo. In tropical regions, this plant is used in elements of house construction, fences, bridges, scaffolding, and is a favourite food of the panda bear. This Brainiac is about to run full speed towards the bamboo, but will he break through or bounce off? It's a bamboo breakthrough! Bamboo might be the symbol of longevity in China, but when faced with a brave and stupid Brainiac, it stands no chance. Bamboo, a thing you can run through.
Here's one for you. Can fat people go skinny dipping?
47-second science. Big science questions answered in bite-sized chunks. If you had to choose, what would be the better way to keep warm? Wearing no clothes, but with your head, feet and hands covered, or wearing clothes, but with your extremities exposed? Time to enter the freezer. Temperature 1 degree centigrade. Our Brainiac will be stood in the extreme cold until it's too much to bear. When exposed to cold temperatures, your body begins to lose heat faster than it can be produced. Eventually, this will use up all your body's stored energy. The result? Hypothermia. Our Brainiac is suffering. His feet are frozen and he has to leave. But this is science. Warm him back up, then strip him, boys. It may not look pretty, but this time all our Brainiac's extremities are covered. 70% of your body heat escapes through your head, feet and hands. So in theory, this outfit should keep our Brainiac warmer. And yes, he's managed to stay longer. In fact, he seems to be enjoying it so much, we have to ask him to leave. 47-second science. Big science questions answered in bite-sized chunks.
Is it a drain specialist? Is it a road sweeper? No, it's Super Brainiac! The result of a mistake in a laboratory. His mission, to rid the world of toxic caravans. Super Brainiac, saving the world with science. Somewhere in Germany, in the small island of Europe, a group of ramblers are enjoying the Bavarian countryside. Then, Donner und Blitzen! This Trail 132 caravan contravenes 5 UN conventions on hazardous materials. It must be stopped! Meanwhile, in Brainiac HQ's What's the Capital of Peru? I Don't Know International Division, the most ordinary of ordinary Brainiacs is desperately trying to look busy. Achtung means the same in any language. Good job, Mom, ironed that suit. Before you can say sauerkraut, he arrives and decides on the perfect science for the job. Today, that science is a balloon filled with a highly explosive mix of hydrogen and oxygen. Carefully does it, Super Brainiac. There's plenty of time to calmly retreat to a safe distance. As each little oxygen atom combines with two hydrogens, a water molecule is formed along with a little bit of energy. But with a lot of atoms, that's an explosive amount of energy. And it leaves only water as residue. And little bits of caravan. Gee, that was close. Thanks, Super Brainiac. You're wunderbar. Has anyone seen Klaus?